So how does a message actually find its way across a network? Well, it's kind of like it follows a map. But what happens when that map is missing a few pages? Today, we're going to follow a single data packet on its journey and really demystify one of networking's most fundamental ideas, static routing. Okay, let's get right into it. You know, every good story needs a hero, right? Well, for us, our hero is just a tiny little packet of data. And just like any hero, it's got a problem it needs to solve. It has to get from point A to point B. But right now, it is completely and utterly lost. All right, so check this out. This is our digital landscape for today. Over on the left, you've got PC1. All it wants to do is send a simple message to PC3 way over on the right. Now, they look like they're connected, but here's the catch. They're in totally different network neighborhoods. And what separates them? These things right here, called routers. And that, my friends, is exactly where our little packet's journey hits a major roadblock. And hey, don't just take my word for it. Here's the proof. When we try to ping PC3 from PC1, which is basically a digital game of Marco Polo, we get crickets. Nothing. The result you see here is a big, fat success rate is 0%. It's like the network is just shrugging its shoulders saying, I have no idea how to get there. So this really brings us to the heart of the mystery, doesn't it? I mean, why can't these two computers talk? All the cables are plugged in, you can see the little lights blinking. So what's the missing piece of the puzzle here? Well, the answer is actually hidden away inside the brain of the network's main traffic cop, the router. See, the problem isn't with the physical roads. The cables are fine. The real issue is that our router is trying to give directions using a seriously incomplete map. Okay, so every single router has this thing called a routing table. The best way to think about it, it's like the router's personal GPS or its little black book of addresses. It lists all the destinations it knows how to get to and the exact path to take. Here's the kicker. If a destination isn't in that table, then as far as the router is concerned, it might as well not even exist. All right, let's actually peek inside our router's brain. What you're looking at is its routing table before we've done anything to fix it. See those lines that start with the letter C? That C is super important. It stands for connected. All this means is the router only knows about the networks that are physically plugged right into it. You know, its immediate neighbors. But what about the network where PC3 lives? Yeah, it's nowhere on this list. It's a total blind spot. So, if the router can't figure out the path on its own, what do we do? The solution is actually pretty simple. We just have to tell it where to go. This is where we get to play network administrator and literally write the directions ourselves. And that, right there, is exactly what a static route is. It's nothing more than a permanent, hand-typed entry in the router's address book. Think of it like we're going out and installing a custom-made road sign that says, hey, to get to PC3's neighborhood, you gotta go this way. And the reason we call it static, well, it's because it doesn't change, ever, unless we go back in and manually change it ourselves. Now, we create this digital road sign with a command called IP route. I know it looks a little technical, but trust me, it breaks down into 3 really simple questions. First, where does the packet want to go? That's the destination network. Second, how big is that neighborhood? That's the subnet mask. And third, and this part is absolutely crucial, what's the very next turn it needs to take? That's the next hop. Notice, you're not telling it the whole trip from start to finish, just the immediate next step to take. And there are basically 2 main ways we can give this direction. The first, a next hop route, is kind of like telling your GPS, okay, start heading towards 123 Main Street. You give it the next address to aim for. This is by far the most common way to do it. The other way, a directly connected route, is even simpler. It's like shouting, just go out the north door. You're not naming the next landmark, you're just pointing to the specific exit to use. All right, so we've looked at the problem, we've written out our new directions, and we've programmed them into the router. So now it's the moment of truth. Let's find out if our little packet can finally get to where it's going. And here it is, the before and after. It's pretty cool. On the left, you see the router's brain with only those C routes, so it's directly connected neighbors. But now look at the right. Boom! There's our new entry, and you can see it's marked with an S for static. We've officially added the missing piece of the map. So what do you think happens when we try that ping command one more time? We get this. Look at that. No more errors, no more frustrating timeouts. Just a beautiful, simple message. Success rate is 100%. Our digital Marco finally got its polo. And just like that, our packet's epic journey is finally complete. It leaves PC1, it gets to that first router, and this time the router looks at its Mac with total confidence. It knows exactly where to send the packet next. It forwards it along the path, and it arrives safely at PC3. Mission accomplished. Okay, so our packet made it, which is great. But, this isn't just some abstract technical exercise. Let's talk about why drawing these digital maps by hand actually matters in the real world. What's the big picture? Really, it all boils down to one word: control. When we set a path manually, we know for a fact that it's not going to change on its own. It's locked in. This makes the whole network's behavior super predictable and way easier to troubleshoot if something goes wrong. And from a security standpoint, it can be a huge win because we've literally defined the one and only path that certain traffic is allowed to take.
And believe me, you see these manual road signs all over the place in the real world. They're absolutely perfect for smaller networks that don't change very often, places where simplicity is more important than fancy automation. But they're also used to set up critical backup paths, just in case the main one fails, or to lock in a specific connection to your internet provider. And like we said, to force really sensitive data down one single, super secure, highly monitored highway.
And all of this brings us to one last really fascinating question. Think about it. What we just did? It was kind of like hand-drawing a map for a small, quiet town. But the internet? The internet is a massive globe with millions of roads that are appearing and disappearing every single second. So how in the world does that enormous, constantly changing map update itself in real time automatically? Well, that is a story for a whole other explainer.